Last two questions were left because the video suddenly stopped at that time. Now one more question was there which says कि an electric field is acting along z-axis and the magnitude of electric field is not constant. It is increasing along z-axis at a rate of 10 power 5 Newton per Coulomb per meter. Now if you are having an electric dipole AB which is placed in this electric field in such a way that direction of dipole moment is opposite to the electric field. It means the charge minus q should be up and plus q should be down. Distance between two charges is 2L. So now the question was saying to calculate the net force and the torque acting on the dipole. Now if you see, say we are taking this point as a reference, say electric field at point B is E. Then distance from B to A is 2L. So electric field at point A will be more and the magnitude wise it will be E plus 2L into 10 power 5 because it is increasing at the rate of 10 power 5. So and secondly direction of force for positive charges in direction of electric field, negative charges in opposite direction. So two forces are in opposite direction. The net force will be minus Q, E plus 2L into 10 power 5 plus Q into E. On solving we get minus q and plus q will cancel. So minus q into 2L into 10 power 5. Q into 2L is dipole moment. So P into 10 power 5 with minus sign, or we can say minus 10 power minus 2 Newton. Direction of force will be from minus q to plus q, means opposite to electric field. Now since the line of action of forces at A and B is same, so no net torque will act on the dipole. Now one more question, last question for the day. Now in this exam, the question was saying two electric dipoles AB and CD. They are placed in such a way that the dipole moments of the two dipoles makes an angle of 120 degree. And say if we place this system in an electric field which is acting along x-axis, then we have to calculate the net dipole moment of the system. Secondly, the torque acting on the dipole. Now you know one thing, again we will apply the concept of vectors. Given like two vectors we are having, the dipole moment both are same in magnitude wise and they are acting at an angle of 120. So we will apply the system ki net dipole moment, because dipole moment is a vector quantity. The magnitude wise will be under root a square plus b square plus 2ab cos theta. We are having p square plus 2p square cos 120. Cos 120, I have already told you how to calculate the value. The value is minus half. So on solving, we get the overall value as P. Direction is given by tan phi is P sin 120 upon P plus P cos 120. Again, we have calculated a similar value in the previous question. Means the question we have discussed with electric field and the question of Coulomb's law. So we get direction is 60 degree from AB towards DC. Now if you see the diagram, AB towards DC, so angle from A will be 60 degree. So from x-axis angle is 30. So now torque will be PE sin theta, and here theta is 90 minus 60 means 30 degree. So torque is PE sin 30, or we get PE upon 2. And direction of torque is perpendicular to both P and E. So we say it is along minus z-axis or clockwise. So similar question, like if you can recall, similar question when two vectors are acting at 120 degree, we have solved in Coulomb's law also, electric field also, now for dipole moment also, and similar questions you can have with magnetic field. So it's very important so to learn and apply the formula of concept of vector addition. So now it's all for the day. Revise the topics thoroughly, and maybe tomorrow or whenever you are having time, you can ask the queries related to it in the group. Thanks and take care.